On April 26, 1986, an invisible cloud, 400 times more potent than the Hiroshima bomb, silently began spreading across Europe. This immediate release scattered deadly isotopes, equivalent to 100 nuclear bombs over the planet, making vast areas instantly uninhabitable. The 2,600 square kilometer Chernobyl Exclusion Zone, a toxic scar on the Ukrainian landscape, remains largely untouched by human activity. Plutonium-239, one of the disaster's deadliest legacies, boasts a half-life of 24,100 years. Your entire recorded human history barely spans 6,000 years. This zone, where humans feared to tread, became a peculiar sanctuary, a terrifying biological experiment run by forces beyond our control. Within 36 hours, 130,000 people were evacuated from a 30-kilometer radius. But the invisible danger stretched far beyond that immediate zone. The radioactive fallout reached 40% of Europe, contaminating areas 2,000 kilometers away. 1 million acres of prime Ukrainian and Belarusian land were rendered uninhabitable for farming or human settlement immediately following the disaster. The initial explosion released 100 times more radioactive material than the atomic bombs dropped on Hiroshima and Nagasaki combined. Pripyat, a city of 49,000 residents, became a ghost town overnight. Across the 2,600 square kilometer exclusion zone, an invisible enemy continued to bombard every living cell, day after day. The radiation dose inside the control room, immediately after the explosion, exceeded 20,000 roentgens per hour. A lethal dose for humans is 500. This silent killer warped DNA, causing genetic mutations in plants and animals at rates up to 10 times normal levels. 38 years later, hotspots persist, where touching the wrong soil could deliver 1,000 times the safe annual radiation limit. A single trip into certain areas can expose you to more radiation than 100 chest X-rays. Plutonium-239's half-life is 24,100 years, a chilling truth that dwarfs human history. For context, the last ice age wrapped up roughly 11,700 years ago, meaning this isotope will stick around for more than twice as long as our entire modern civilization. While cesium-137 and strontium-90, common contaminants, fade within 30 years, plutonium-239 is the real long-term threat. These dangerous elements bind to soil, tainting plants and animals for ages. The contaminated zone will remain a radiation hazard for an astonishing 800 generations. A stark warning passed down through time. It's creepy to think about. Human habitability across the 2,600 square kilometers remains a distant dream for at least 20,000 years. This invisible poison leached into the soil, corrupting life's very foundations. An estimated 116,000 people were permanently displaced, creating a ghost population from an unseen enemy. Small, isolated hotspots still pulse, radiating over 100 chest X-rays per hour locally. This constant, low-level exposure silently breeds genetic mutations and weakens immune systems in countless organisms. Your phone battery? A single day. This radiation? 24,100 years. We're essentially fruit flies against this timescale. Scientists are publishing over 1,000 research papers annually, treating this place like a grim ecological experiment. Yet, nature, slowly but surely, is reclaiming this forgotten territory. In Chernobyl's exclusion zone, wolf populations are 7 times denser than in surrounding natural areas, a strange truth born from human absence. The land scarred by nuclear disaster somehow became an accidental sanctuary. Today, over 200 bird species thrive, their nests dotting forgotten buildings and trees. Large mammals like wild boar and deer, once driven out, now roam with astonishing freedom across plains and forests untouched by human footsteps, their numbers rebounding dramatically. Even the critically endangered Swalski's horses, reintroduced in 1998, now exceed 150 individuals, a surprising conservation success. These animals are the unexpected inheritors of a poisoned chalice. At the very top of this reborn wild kingdom sits the gray wolf, with estimates suggesting over 300 now inhabit the zone. They thrive in packs, communicating through a complex language of howls and scent markings. Honestly, evolution practically said challenge accepted here. These intelligent hunters, with senses 10,000 times sharper than ours, track abundant deer and boar through vast territories, often 100 to 250 square kilometers, patrolled with silent efficiency. Despite the lingering radiation, life flourishes, with females giving birth to healthy litters of 4 to 6 pups, a powerful symbol of nature's resilience. The Chernobyl Exclusion Zone has become a wild kingdom reborn from tragedy, where humanity's absence allowed another kingdom to reign supreme. It's a stark reminder that even in the face of unprecedented disaster, life truly finds a way. In Chernobyl's exclusion zone, small mammals like voles show mutation rates 20 times higher than outside. This isn't just survival, it's active evolution, life adapting to an environment permanently reshaped by radiation. Scientists are spotting incredible genetic changes in its thriving gray wolf population. These Chernobyl wolves have a unique immune advantage, boasting up to 15% more antioxidant glutathione than their outside counterparts, a biochemical shield against chronic radiation. This allows them to flourish where we can't. Certain fungi and bacteria here are actually radiotrophic, literally consuming radiation for energy. Research also reveals wildlife cells in the zone can mend DNA damage 30% faster than average, a biological express service for survival. These adaptations aren't identical across the board. Different species show varying resilience, a clear sign of evolutionary pressure. In the Red Forest, a heavily contaminated area, we see the most striking mutations, like altered tree growth. Some rodent populations, for instance, have thyroid glands up to 50% larger than normal. Scientists also found birds here produce more antioxidants and exhibit better DNA repair, directly tied to their radiation exposure. It's a stark contrast to the initial impact. Many species saw reproductive success drop by as much as 25%. And then there's the wild boar, rooting near an abandoned building, a symbol of this enduring, albeit fundamentally changed, existence. Born from catastrophe, the Chernobyl Exclusion Zone has become one of Earth's most intensely studied environments, hosting over 200 research projects. They're scrutinizing everything from fungal radiation resistance to wildlife genetic mutations, more studies than most national parks see combined. Scientists are particularly fascinated by Chernobyl tree frogs, which have developed much darker skin to protect against UV and radiation. Researchers meticulously monitor radiation levels, finding specific bacteria and fungi that can survive doses 1,000 times higher than what kills a human. It's a testament to life's adaptability. The zone offers a unique, long-term natural experiment on chronic low-dose radiation's effects. Studying these resilient organisms helps us understand genetic repair, evolutionary processes, and potentially develop new strategies for radiation protection. Even gray wolves inside the inner zone carry radiation levels up to 300 times higher than those living outside. Yes, that's a real number. Some Chernobyl wolves exhibit genetic mutations that seem to confer resistance to cancer, a remarkable adaptation to chronic exposure. Their immune systems show alterations, producing more anti-tumor proteins compared to wolves from unaffected regions. It's an evolutionary fast track, and honestly, a bit creepy. The wolf population inside the zone thrives, reaching 300 individuals, each pack controlling 40 to 60 square kilometers. They observe these wolves thrive with internal radiation 300 times higher than human deadly levels, showcasing incredible resilience. This resilience impacts the entire ecosystem. As apex predators, wolves influence wild boar and deer populations, shaping the zone's food web. Studying these irradiated wolves offers unprecedented insights into radiation resistance, potentially informing future human medicine or strategies for space travel. Chernobyl's final lesson isn't just a number, it's a stark 20,000-year testament to our lasting impact. That immense timescale dwarfs all of human history. A quiet but forceful reminder as nature slowly reclaims our mistakes. The genetic legacy of this catastrophe is an ongoing, unasked-for experiment, forcing us to confront the unintended consequences of our ambition. Yet life within the zone demonstrates astonishing resilience, defying our neat categorizations of disaster. It stands as a permanent global monument, a sarcophagus of human error now home to wildlife thriving against the odds. Wolves, bears, and lynx flourish, their genetic diversity often higher than in nearby, less affected areas. Gray wolves, precisely where you'd expect them to falter, have seen population increases up to 7 times greater than in adjacent, less contaminated zones. This accidental laboratory offers unprecedented insights into ecological recovery and evolution under extreme pressure. Evolution, it seems, looked at the irradiated wolves and thought, adapt, improvise, overcome. Cleanup costs already exceed $500 billion, a figure that makes other environmental disasters pale in comparison. Our ability to contaminate for millennia so dramatically outpaces any recovery, demanding a serious re-evaluation of how we manage our planet. For the next 20,000 years, this will stand as a testament to our technological hubris, a wild, glowing scar on the Earth. We are merely transient visitors in geological time, yet our actions cast shadows that span epochs. The visible scar stretches 2,600 square kilometers, an area larger than Luxembourg, remaining uninhabitable for generations. It's the resilience of the gray wolf, thriving despite the 24,100-year half-life of plutonium, that should humble our greatest technological achievements.